Once I say your name, you can put your hand down. Lauren, Nika, Brooke, Peyton, Sydney. Is that everybody? That's Monday, Tuesday, next week. All right, I will let you know what will be happening, and I'll get you anything. Okay.
I don't know.
Okay. All right, 5, 5, or 6. What quadrant is that in?
Second.
What's the reference angle?
30.
So what did you get?
1/2.
1/2.
Oh, I got -1/2.
So the only thing that's negative there is this.
Oh.
All right, we spiral back to the very beginning of the chapter. So basically, this review set this week is going to be great for you for the test Friday. So you're not going to have a little quiz over it. You're going to have just the chapter test. Okay. So it's all trig. It's just the whole chapter. So this guy here.
Down as a test Friday.
How many minutes are in a degree?
60.
So those cross out and you get 12/60. I'm not even going to simplify that yet. And then the 52 part. How many minutes, seconds, sorry, are in a degree?
3,600.
What's the purpose of the whole degree minute second system? Out of curiosity.
Yeah, measure more precisely. Okay, see this 52/3,600? And the 12/60? And the 43? What do you do with them? Add them together. We haven't done that yet. Punch it in. Tell me what you get when you get it.
I got 43.3.
2, 1. 2, 1, 2, 1, 4, 4 repeating.
Not yet. Not yet. So do we find the average of those? Is that what we do?
No, you're adding them together.
Oh. Why is it in the decimal? Why is it decimal?
Okay, guys, number 3. This, in theory, should be easy because this is the thing we just did, right?
Yeah.
But it's been almost a week. So, what's the very first thing you need to do before you start answering
Take
anything?
that 2 out.
I like how Brian, take that 2 out. All right. Brian, when I take the 2 out, what's here?
Pile 2.
You got it. All right. All right. So, Josie, tell me anything you know about this graph.
It moves up 1.
Of 1. Good. Marina, tell me something else.
The amplitude is 2.
Grant, can you tell me something else?
It shifted right pi/2.
Perfect. And I need to know P. Logan, you have P? How do you get that?
2 pi/2.
Yeah, 2 pi over the B value, which is pi. Okay, perfect. We have everything we need. So then every 4 is pi. And then I'm going to do my F1. 2 and down 2 from there. And where should sign start? Mid-centered or top? Okay. So it does, but it's moving to the right. So it should start here, but it's moving to the right. So there's my happy starting point. And then I like to go sign to the right, like that, and then go backwards. It just seems natural. And then the real test is, can you do it in all one motion without messing up? I'm gonna try. The first class I did not, but I'm a little more focused at this moment. There we go. Any questions? Questions, any?
No, it's all right. I think it'll be figured out.
Are you sure?
Yeah. Yeah, I know where it's at.
Okay. So you picked up 4-7 on your way in, grab that.
I know. That's the best thing we did.
Oh, God.
I'm sorry, I'm just, it's just, it's not
All right. So I forgot to ask how break was.
I wish we had a day off.
Lots of sleep. Wish we had to stay off.
I ate a whole apple pie.
Yeah, one or two.
This was late.
All right. Well, I hope you had a nice break. More food? I'm still riding on leftovers.
I ate a whole apple pie.
Dude, we have
A whole apple pie?
I don't even have that shot. I can't do it.
My mom did.
I need certain things.
So, all right.
Yeah, just
I know. It's the right thing to do. All right. We should start. I do want to say though, my big news over the break was that my daughter turned 3. So I have a very sassy 3-year-old daughter.
Wait, what's today?
So here's the best part about my daughter's birthday. Are you ready? Because I don't think I've told you this yet. Tell me what is amazing about my daughter's birthday.
It's 1, 2, 3.
It's Fibonacci.
Yeah.
She's a Fibonacci baby. And my master's thesis was on Fibonacci. I love Fibonacci.
Oh
my God, it's a message from God.
And it was so meant to be too, because she was a whole month early.
Whoa.
She wanted to be born on Fibonacci Day.
Mom.
So,
I said, it's 1, 2, 3.
you were so
Magic of Jesus.
Alright. Don't worry, we're gonna do Fibonacci. Alright.
You mean the triangle thing?
No. Alright. Picture sign. Right? Right?
Yes.
Can you picture that? Can you imagine inverting it? Like taking it inverse? What do you do when you take the inverse or find the inverse? You switch the x and the y, yes?
Maybe the same thing.
It's not.
Zero thing.
Oh, wait. Nick said what? Is it not a function? What do you guys think?
It's not a function. Is it that? Yeah. It's not.
Yeah.
Now, wait. Yes. So how did we know from the original function that its inverse wouldn't be, Logan? The original does not have horizontal line test, right? So when you invert it, it's going to have duplicated x values. Yes? Okay. So that's what we're going to write down to 5. So in chapter 1, we learned every function has an inverse relation. Okay? Relation. So relation just means any old graph. Doesn't have to be. And that this inverse relation is a function only if the original function passes the horizontal line test. And we gave 3 words to that. Yeah. Only if the original thing is 1, 2, 1. So what I was getting at, the 6 basic trig functions, sine, cosine, tangent, right? Secant, cosecant, cosecant. Do any of them pass horizontal line test?
No.
You don't, right? No. But we found a way, mathematicians have found a way, to be able to study the inverse even though tech isn't a function. So what do we have to do?
I wish they wouldn't do that.
So here's what happens. And I like Desmos for this. Okay, so here's what it would be, right? Imagine just chopping it. Okay, because don't you see how you're getting repeated values? So what if you just chop it? And look, if you actually just put in the sine inverse instead of what I did here, it chops it, and it's only using this portion, and this is really cool.
And that looks like a function.
And that is a function, exactly. So look at this point right here, -1, -5. And 1 times, okay? So what do? We restrict the domain. So I'm going to take you through the original graph, and then we're going to invert it. So we're going to graph sine on the interval -π halves to pi halves. Okay? So put a tick mark here, -π halves, here, pi halves. How high does sine go? And how low?
How high?
How high can you go? How low can you? Never mind. Forget it. It's gonna erupt.
Just everywhere.
Okay. Here's sine. We're graphing sine.
No, I just don't get the reference.
My joke is dumb.
What was your dumb math song?
That was too connected.
Everybody, let's all sing the quadratic formula song.
No, please.
One.
No.
No, you don't pause.
No, please don't.
Okay,
Please don't.
Sorry.
I'll let you
it
get
wasn't-
away
it
this
wasn't-
time.
Oh, it was
So get off of Bright side.
Brian, if you need to
No, I'm
disconnect
good.
from the pod a little.
I had to, that's part of the reason I wanted over here, so he wasn't on my lap. It's just you.
Okay, what's the domain? Is -π halves to pi halves.
Uh-huh.
And what is the range?
1 to 1, 1 and -1.
Like, I love you, you're so crazy.
-1 to 1. Okay. Now, so when we invert this, they're gonna switch spots, right? Domain is now the range. Range is now the domain. And over here, you're gonna see the graph that Desmos drew so beautifully for us. So our domain now goes from -1 to 1. And our range goes from -π12 to π12. And you can see that by doing that, our points switch places on their own. So this point, -π12, -1 becomes -1, -π12. 0, 0 stays put. And then this one switches places as well. And then for this part, I just remember the curvature changes. So looking here, see how this is up and now, and this part's down, which is opposite of what we had here. This was down, and this was up. And I don't know that you've heard this terminology, but some books use, instead of sine inverse, they use arc cosine. Arc sine, which is equivalent. All right, so that's sine inverse graph. Ready? You know what's going to be next. You guys didn't interrupt in between slides. All right, check it out. If I switch x and y for cosine, you're going to get a similar thing happening, yes? Okay. Now here, and I'll do this more in a second. Instead of restricting it -π12 to π12, you'll notice it's 0 to pi. Oops. So here you're restricting it here to here. Okay? So you're just using a different piece of it. So let's, oh my gosh, sorry. I'm gonna close this right now so I don't do that again. Okay. All right, so let's graph cosine just normally from 0 to pi. So domain is 0 to pi, and range is -1 to 1. I'm going to swap them. Again, the points are switching places. So like 0, 1 becomes 1, 0. Π12 0 becomes 0 π12. And pi -1 becomes -1 pi. And again, you can do the opposite curvature.
How do we get these values? Do we just memorize them?
Well, this is the regular cosine.
Oh.
We're just switching everything. Now, looking at the graph again, so up and then down, curvature. So up and then down. In calc, we'll call that something, but for now, I'm calling it curvature. So, makes you excited.
I'm excited.
Now notice, everything lines up. This point, this point, this point are what we had. Well, let me label it. Why? Oh well. Okay, and then last but not least, we have tangent inverse. So just like the others, if we were to just invert every part of it, it would not be a function at all. So if we restrict it, we're just going to look at that middle section there. And that's the definition of the tangent inverse. Okay. So again, we're going to start by graphing the original tangent. Delivery. Hello.
Because he golfs.
Did you make a good call?
No, it wasn't good. I just said chill out, golf man. It wasn't even a joke.
Why did they put weirdos in the same class together?
That's not the first time he's done this.
I'm just gonna graph tangents.
Yeah. We're gonna go right around that one.
Okay, so we're graphing one cycle of tangents on negative pi halves to pi halves. So this is not new, this part.
You know, the other night I accidentally messed up.
We don't wanna
I
hear
can't
about it.
remember.
All right.
Good.
Sorry. I don't understand. I don't make good graph.
Okay, the domain is negative pi halves to pi halves. What's the range? You got it. Okay, your switcheroo.
What did you say instead?
Does Aiden like your offer?
So instead of vertical asymptotes, what is the inverse asymptote? Yeah. So we have horizontal at pi halves and negative pi halves.
Sorry,
Guys,
Brian, I'm taking all your space. You're fine.
and switching around our x and y values, we've got our tan inverse graph here. Abby, as we go to the right, where is it heading towards?
Infinity. Or no, pi over 2.
As we go to the left, where's it heading towards?
Negative pi over 2.
Got it. That's our end game here. So limit as x goes to infinity is pi over 2. And limit as x goes to negative infinity is negative pi over 2. Okay, and while we have these graphs in our head, I'm going to ask you to skip ahead a couple slides. I know, crazy, and we're going to come back. to the slide that says like state the transformations and graph. Right here. Is it right before the homework? Right before the homework.
Just reached a milestone, just reached 35 supporters, so shout out to my, shout out to my science.
All right,
I have no veins.
so the transformation rules work just like they always have. So what does the 3 do?
I'm so buff. Not.
What? So these technically don't have amplitude.
Is that just a-
It's a, it just look, it's not horizontal, vertical stretch by 3. Now, the other part, this has been a while,
Wait, that's the wrong page.
this one, no, he's good.
That's it, bottom one.
Okay, now, this has been a while,
No.
do you guys remember rewriting 2x like this?
No.
Yeah. That's the horse.
Yeah, so now we know which way does it go horizontally, stretch or shrink? Shrink by half, right? So we had those rules, you can look way back, x over c. If c is 0 to 1, it's a shrink. If c is bigger than 1, it's a stretch. So this is gonna shrink it horizontally by half. So we're stretching it this way, we're shrinking it this way.
I see the horizontal strength. I'm a little confused on the whole thing.
So do you agree that 2x could be rewritten like that? Because you could flip and multiply.
Yeah, I see that.
So we had these rules a long time ago, f of x over c. And if c was between 0 and 1, it was a horizontal shrink. And if c was bigger than 1, it was a horizontal stretch. It was quite a while. It was like 1.7, I think. 1.6, something like that. Okay. So then, while these were in our heads, I wanted you to think about if I am, it was cosine, right? It was cosine?
Yes.
So if I'm stretching it vertically, oh, sorry. Okay, if I'm stretching it vertically, what does the pi become? 3 pi. And then what do these become?
1/2.
Yeah, half, right? Because we're going in by half. So it's just really all about the labeling. So label this 3 pi instead. And then label this -1/2 and +1/2. And then you can just fill in the 3 points. And the shapes will be the same. Domain will be -1/2 to 1/2. And the range will be 0 to 3 pi. Question, comment? Okay, see if you can write down the transformations for this.
How do we know it's a horizontal? Where did the shrink come from?
The horizontal stuff comes from the inside.
Oh, so 2x, so 2x translates to 1/2 horizontal shrunk.
That's
Oh, so because shrinking by half is the same as multiplying by 2. Oh, because dividing by half is the same as multiplying by 2.
Yes.
I'm sorry.
Let's go.
Can you tell me one of them?
Vertical shrink by 26.
Perfect. And Brooklyn, do you have the other one?
Horizontal shrink.
Close. So the 3 is already on the bottom. So it's like the C value is 3.
Oh, okay.
So it,
Yeah, stretch.
there you go. Okay, so I'm gonna take you back to the graph real quick and see. Here's our original graph. Shrinking these by a 6 is the same as multiplying by 1/6. Right? So pi falls. And then these will just become 3s. Okay, it's not gonna change our domain at all, it's still gonna stretch all the way. But it's just gonna be out 3 instead of 1.
Okay, will you go back and almost done with the original?
I was just looking at the old graph. I'm about to graph it right now. Okay? That wasn't this graph. I was just referencing that page.
I figured we'd let him finish getting what he didn't get on it. Nope.
Yeah, we're back to
Right.
Actually, Mr. Hughes is fairly
Well, that's good. I have to look at the clock.
After this graph, I'm gonna have to. You enjoy torturing me like this way. I'm starting to fart because I feel really bad. I'm put up with that, but you wanna let me go. See, I have ammunition. You all needed another day, Michelle, and you get one. The best you can get is better than great.
Oh, that's.
Alright, domain and range are there.
Go to that bathroom and don't get lost through breadcrumbs.
5-minute limit.
You hear that?
Yeah, 5 minutes.
Yeah. Oh, wait, give me your phone.
You're too smart.
I wasn't even thinking.
Yeah. I thought you were right.
I am. I'm not sorry.
Like I used to.
Yeah,
Yeah, take them things like.
I'll show you.
Egregious.
So it looks like
I did.
this program.
I don't
So it wants that. When I go to next, it wants this.